All right, here are solutions to quiz 7 for Math 251. You're told that the derivative of arcsine is 1 over the square root of 1 minus x squared, and you're asked to find the derivative of 2 times arcsine squared of x squared. I think it helps to rewrite this. So really you're asked to find the derivative of 2 times something squared. And that something just happens to be the arcsine of x squared. And so if you read it like this, it's a little easier to see what you do. We'll first bring that 2 down in, take care of the constant, bring that out in front, and say it's 2 times the derivative of arcsine of x squared. So this will be some chain rule, or rules, I guess, in this case. My outermost function is all this stuff being squared. So I'm going to take the derivative. I'll bring this 2 down in front using the power rule, and 2 times 2 gives me 4 times arcsine of x squared to the first power. But then I'm not done. I have to multiply that by the derivative of arcsine of x squared. Well, the derivative of arcsine of x is this thing. So the derivative of arcsine of x squared would be 1 divided by the square root of 1 minus something squared. But I don't just want to put an x there because I'm taking the arcsine of x squared. So in place of the x here, I'll write x squared. And then I'm still not done. I have to multiply by the derivative of x squared, which is 2x. This is a perfectly good answer written in blue here. Or if you want to clean things up a little bit, you could say it's 8x arcsine of x squared divided by the square root of 1 minus x to the 4th power. Either of these are totally fine. And there's other ways you could do this problem. You could even set it up, do implicit differentiation, and then sort of take the sign of both sides of the equation at some point. But since this was the inverse trig function, I'll leave these as my answers. Okay, and then moving on. Number 2, it's no longer inverse trig. You're dealing with logarithmic differentiation. So in this one, I just have a function that happens to have a natural log in it. And so you have a few options in terms of how you do this. You could use log rules here, or you could just take the derivative. The derivative of 2 raised up to some stuff. Well, if it were just 2 to the x, it would be 2 to the x. I think I want another x in there. I'm going to make this x squared e to the x is what I'm going to do. Did I do that on purpose? I don't remember if I made this just e squared on purpose to hide. Like, that's a complicated looking constant. But what I'm going to do is I'm going to change this and make it the derivative of 2 raised up to the natural log of, and then x squared e to the x. So that's the problem you'll see on your test, and that's what I'm going to solve. And when I'm solving that, taking the derivative of 2 raised up to stuff is just 2 raised up to that stuff times the natural log of 2. But then since it's the chain rule, you're not done. You have to multiply by the derivative of that stuff. And so the derivative of the natural log of x squared e to the x, I could say, well, the natural log part is 1 over x squared e to the x. And then I will multiply that by the derivative of x squared e to the x. And for that, I'll use a product rule. And so f prime times g plus g prime times f. So I'll end up with something that looks something like that. And this is a perfectly good answer. You could simplify this if you are so inclined. And I'm just going to say we could also set it up differently. We could take the derivative of 2 raised up to the natural, how about 2 times the natural log of x plus the natural log of e to the x, which is just x. So if you wanted to do some log rules right off the bat, you could rewrite the problem so that it looks like this. In which case you'd get 2 raised up to some stuff, that stuff being 2 times the natural log of x plus x, and you multiply by the natural log of 2, but then you're not done. You have to multiply that by the derivative of the stuff. Well, the derivative of the stuff in this case would be the derivative of 2 times the natural log of x, which is 2 times 1 over x, plus the derivative of x, which is just 1. So here's 2 different ways you could do this problem. You get pretty different looking answers. If we had the inclination, we could show that these things are equal. Let's see, this shows up in both terms, or in both answers. So really have to show that 2 over x plus 1 is the same as this mess, which you can kind of see if you put this up on top. E to the x squared divided by e to the x squared would make this 1. And this over this would make the 2 to the x. So anyways, I think that's more than enough on that problem. Next one. This one, you're told to take this mess of a derivative. What I had in mind here is to use implicit differentiation. So say that y is equal to x to the 5th times e to the 2x power times x plus 1 to the 1/2 power times the arc sine of x squared times 5 to the x power times the natural log of x times, I probably went a little bit overboard here, the sine of 2x cubed. And the reason I thought it might help you to set it up like that is then you could say the natural log of y is equal to the natural log of all this stuff, which if I use a bunch of log rules, I can say it's 5 times the natural log of x plus the natural log of e to the 2x, which is just 2x, plus 1/2 times the natural log of x plus 1, plus the natural log of arc sine of x squared, plus x times the natural log of 5, plus the natural log of the natural log of x, plus 3 times the natural log of the sine of 2x. Yeah, I definitely went overboard. Okay, so then what you get on the left-hand side of the equation when I take derivatives is 1 over y prime. And on the right-hand side, this 5 is just a constant. The derivative of natural log of x is 1 over x, so I get 5 over x from this, plus 2 from this, plus 1/2 times 1 over x plus 1 times the derivative of x plus 1, which is just 1, plus 1 over the arc sine of x squared times the derivative of arc sine of x squared, which as we saw above is 1 divided by the square root of 1 minus x squared squared, times the derivative of x squared, which is 2x, so a few chain rules going on in there, plus the derivative of a constant times x is just that constant, natural log of 5, plus chain rule here, the natural log, the outside one, of the natural log of x, times the derivative of the inside stuff, which is 1 over x, plus 3 is just a constant, natural log of the sine of 2x, times the derivative of the sine of 2x, which is cosine of 2x times 2. So your answer, y prime, is equal to y, which I'll be lazy. I'll say it's all this stuff, times all this stuff, which I won't be quite as lazy. I'll rewrite that. 5 over x plus 2 plus 1 over 2 times x plus 1 plus, let's see, 2x divided by arc sine of x squared times the square root of 1 minus x to the 4th. That's this term here. Plus the natural log of 5 plus 1 over x natural log of x, that's this term here, plus 3 times 2 gives me 6. Cosine of 2x over sine of 2x would give me 6 cotangent of 2x, if you felt like writing it that way. And I'm going to call that good because I don't want to write anymore. And then this last problem, you were told to find the derivative of the natural log of x raised up to the natural log of x power. So what you do here is, again, set it up as implicit differentiation. You got y is equal to the natural log of x raised up to the natural log of x power. So if I take the natural log of both sides, I have the natural log of y is equal to the natural log of something raised up to an exponent. So what I can do is take that exponent and bring it down in front. So this natural log of x comes down in front, and that's getting multiplied by the natural log of the natural log of x. To get those all right, let's see. So I took this natural log of x and brought it in front here, which left me with the natural log of the natural log of x. So I get here. And now I can take derivatives. I get 1 over y times y prime is equal to product rule, f prime times g plus g prime times f. So I get that y prime is equal to y times And then over here I got the natural log of the natural log of x over x. And over here my natural log of x and my natural log of x cancel out, and I just get 1 over x. So y prime is equal to y, which is the natural log of x raised up to the natural log of x power, times this thing, which I could rewrite as the natural log of x. Let's see, I'm not going to be able to fit that in up there. Times the natural log of the natural log of x plus 1 divided by x. This is what goes in these parentheses right here. And then this serves as my final answer. I think I'm going to spread this out a little bit more so you have 2 pages to write this because it's a bit overboard. But I'll end the video here.